Mallia. Today I am going to discuss on discriminant analysis and logistic regression analysis. Prior to that, I would like to say our previous chapter was linear regression and correlation. So the link actually started from correlation, and correlation is related to regression, as we discussed in that previous chapter, that if there is no correlation, then it is too difficult to go for regression analysis or to predict the regression or predict one variable when another variable is given. So after that, we found some difficulties, like if there are set of independent variable, because in linear regression we are having only one dependent variable and another independent variable in the linear regression equation. But in actually real life, we will face a set of combined effect of independent variable on dependent variable. So in that case, we discussed about multiple regression analysis. Then it is also related to discriminant analysis and logistic regression of multiple independent variable. So in this chapter, we are having the contents like the introduction of multivariate analysis, of discriminant analysis and logistic regression. Then we will talk about how discriminant analysis is calculated, a numerical example we have given in the discriminant analysis. Then we have also discussed how we will use SPSS package for calculating this type of analysis in our research. Then we discussed about the applications of discriminant analysis. After completing all the discriminant applications, then we will move to logistic regression, which is most useful in marketing research. Also, we have given some applications and use of SPSS of logistic regression analysis. Then we differentiate between logistic regression and discriminant analysis, how they are useful in both marketing research and other research aspect for a researcher. After completion of this chapter, we will be able to appreciate the application of these areas, discriminant analysis and logistic regression analysis, in the context of marketing research. We will also be able to explain how discriminant analysis and logistic regression analysis are computed both by manually and also by the use of SPSS. Then we have differentiated between the logistic and discriminant analysis. Then after that, we have discussed some application of this concept of linear regression, logistic regression and discriminant analysis in our real world marketing decision problem and its solution. Let us come to the introduction, the content one. So here we will discuss two methods of multivariate analysis. As we said, in linear regression analysis, we are having only two variables. One is dependent, another one is independent. But in multiple regression analysis, what we discuss, now there are n number of variables are there, and we can say there are set of independent variable. So what the independent set of independent variable as impacting, or how it is affecting the dependent variables, that we have discussed in the multivariate analysis. So one of the method, or we can say the methods of multivariate analysis are of two types. One is discriminant analysis, second one is logistic regression. So in both the method, we have set of independent variables, and how it is useful and how we will apply in our marketing research, that we will discuss. So it is useful in situations where the total sample could be classified into mutually exclusive and exhaustive groups on the basis of a set of predictor variables. So in our previous discussion, we know that what is predictor? Now predictor is the independent variable that will predict the dependent variable. So here we are talking about mutually exclusive and exhaustive groups. So before completing this definition, we must understand what is the meaning of mutually exclusive. Mutually exclusive meaning is if I have two things. Just take an example of I'm a user or a not user of a product. We can say a success and a failure. If there are two sets, success and failure, so both the person who is success, that person cannot be a failure. Or vice versa, if a failure person is there, he or she cannot be termed as a success person. So both success and failure, if there are two sets of people, so they cannot be overlap with each other. We cannot say the same person is success in the same game or same situation as well as he or she is the failure in the same situation. It is not possible. So this is the meaning of mutually exclusive. Mutually exclusive means there is no common points or no unions exist between two sets of object, aspects or persons. We can say this is the understanding of mutually exclusive. Means they are not, we can say, overlapping cases are not there. And what is exhaustive groups? Exhaustive means for a particular situations, what is the all possible outcomes is known as exhaustive. If I am talking about the user of a particular product in my marketing research, then what is the possible user? What is the total number of possible user? That number of possible user is termed as exhaustive group. And as we already discussed, what is mutually exclusive means user and non-user. If there are two sets of people with me, then these two sets is known as mutually exclusive with each other. Let us again come to the definition of the discriminant analysis. It said it is useful in that situation where total sample could be classified into exclusive and mutually exclusive exhaustives and mutually exclusive groups. Means while going for any kind of research, we must check, or if we find something is there, the customers or the situation or the respondents are classified into different groups, then in that case it is wise to use the discriminant analysis. And what groups? Now that groups is framed in such a way that the groups are mutually exclusive with each other as well as the groups are exhaustive in nature. For example, I have cited one example here to understand the above paragraph, that one may wish to predict whether sales potentials in a particular marketing territory will be good or bad. So here I turn to name that good and bad, or good or bad. So good is a set of element I can say, or people I can say, some product I can say is good is a term and bad is a term. So both are opposite with each other. And if I will gather some information on good and bad, I will definitely find no element which will exist in good as well as exist in bad. So both are mutually exclusive. So it is a case where we can apply discriminant analysis. So here, good or bad based on territory's personal disposal income, population density and number of retail outputs. So here set of independent variable we have. So we may like to classify a consumer as a user or a non-user. If we are talking about this situation in the marketing research, as I said, for a particular brand or for a particular product, I can distinguish in two categories. That is either a user of this product or non-user of that brand of a product. That is also based on some factors like demographic factor. We can say age may be a factor, income, length of time spent in each present job. All these things are the predictor of the two sets I have framed, that is user and non-user. So here the interest is what variables discriminate well between the groups. So what we found actually In the set of independent variables, we found that we have two groups, that is user and non-user. Actually, these demographic factors actually impacting these two variables. So it is called discriminant. There definitely will find some discriminant in between these groups. So if we understand the purpose of this, the discriminant analysis, then here we can say to classify objects into predefined distinct groups based on their characteristics. It may be demographic characteristics, it may be other characteristics. According to the research, what we are doing here, now we are classifying the objects. Then we use a set of explanatory or predictor variables. The variable, as I discussed, it is the independent variable that will predict the independent variable. It's known as dependent variable, or you can say the reverse of independent variable, or predictor or explanatory variables measured for each object. Suppose I classified few objects, then what I will do? Now I will use the set of predictor, the variable who is actually predicting these objects which I identified or classified. Then the mechanism we will use, that we will create mathematical functions that best separate the groups based on the predictor variables, minimizing difference between groups while minimizing difference within the group. Again, there are two things we are talking. In ANOVA also the same thing we have discussed, that within the group and between the group. Suppose I have two groups. One group is user of the brand product, second group is non-user of the brand product. So if I am finding any kind of differences inside the group user and non-user, so this is called within the group differences. Means suppose I have 11 elements or persons inside the user, then if I found there is some differences in between these 10 people, then it is called within the group differences. Then talking about the group between group differences, it means the differences between these two different groups separately, like user and non-user. If I found some characteristics in between them, user and non-user, and they are different with each other, it is called between group differences. But what we are trying to do here in the discriminant analysis, now the mechanism or the mathematical functions we are using here in the discriminant analysis to maximizing the differences between within the groups while minimizing the differences within the groups, which is most important. We generally used to minimize the groups, the differences within the group. Means those are, though we have two groups, user groups, so there should not be more differences inside the group. It may happen the differences outside the group, means group differences may considerable, but not within the group differences. It should be minimized. Then what we will get as an outcome, now assigns new object to one of the predefined groups. Suppose instead of user non-user, we can use loyal and non-loyal. So here, based on their scores on the discriminant functions derived from their predictor variables, we can get as an outcome. So how we will, where is the situation where we can apply the discriminant analysis? Now we can use this discriminant analysis like problems where some classifications or grouping policies or study is there in my research. Like suppose I have two groups, like those who are liking the group, those are not liking the group, like success and failure of a product, high and low performer of the employee in a employer or in a job place, or we can say some different possibility, those are actually opposite or mathematically opposite with each other in my marketing segments, then in that case we will go for the discriminant analysis, or we can say it is the only method which can solve such kind of problems for my research. So objectives of these two groups in the discriminant analysis is that the finding the linear composites of the predictor variable that enables the analyst to separate the groups by maximizing among groups relative within the group variation. So what the objective, the most important objectives are? Now the first one is the linear composite of the predictor that will enable us, that the analyst or the investigator, that to separate the group differences, or we can say maximizing among the group differences, but at the same time what we are doing in the discriminant analysis, we are minimizing the group variation inside the group. Then the second objective is to establishing procedures for assigning new individuals whose profiles but not group identity are known. What he said, establishing procedures for assigning new individuals. So here we are going to assign some new individuals whose profiles but not group identity are known. Maybe their profiles are known to me, but the group identity is not known to one of the two groups. In that case also, the discriminant analysis is applicable, and this is the second most important objective of the discriminant analysis when we have the groups, but the identity is known to us, but not the identity is not known to us, but the profile is known to us within these two groups. And third one is the third most important objective of the discriminant analysis is to testing whether significant differences exist between the mean predictor variable profile of the two group or not, which is actually important in the marketing research basically. And the fourth, last but not the least, determining which variables account most for intergroup difference in mean profiles. As we know, profiles are known, but group identity is not known. If this is the case, so the last objective says we are determining which variable actually account most for the intergroup differences between the mean profiles. So the profile which is known to us in the mean profile, how these variables are account to creating intermean or intergroup differences that can be specified and calculated in discriminant analysis, or we can say the multivariate analysis. So the same thing we can see here with the help of an example, that a numerical example I have cited here. There is X1. In that example, ready to eat cereal is there, which is presented in the regression analysis we have already discussed. But in this problem, the 10 consumers raters are simply asked to classify the cereal into one of the two categories, that they likes or dislikes. So X1 as a variable, we took the amount of protein per standard serving. It is visible here. Protein X1 is represented for protein, and as per the standard serving parameter, and X2 is another variables we have cited here, the percentage of minimum daily requirements of vitamin D per standard serving. So X2 contain the standard parameter for vitamin D, and X1 stands for the protein. Two variables we have defined. Then as per the discussion, that we want to categorize them as likes and dislikes. The persons who likes proteins, who likes vitamin D. Similarly, the persons who doesn't like protein and the person who doesn't like vitamin D. So these are two categories now with me, or we can say two groups. And if we examine these two groups, both are mutually exclusive in nature. See, so what we find, these are the dislikes parameters in the above we had mentioned for x1 and x2. Similarly, under that, the below portion of the table contain the likes, or we can say the persons who likes protein and vitamin D also. Here we have calculated the mean of protein dislikers and mean of vitamin D dislikers. For the function or the for putting or to run a mathematical model for the discriminant analysis, we require some further calculation that we have done here. As it is visible, it is shows x1 square means x1, if the person in category dislike, it is 2, so it becomes 4. Similarly, in x2 it was 4, it becomes 16. And another column I had added, that is x1 and x2, means the respective value of x1 is multiplied with respective value of x2, and I have interpreted here. That is 2 into 4 equal to 8, 3 into 2 is equal to 6, 4 into 5 equal to 20. In that way, we have calculated the mean of dislikes, those persons for protein and vitamin D. The same way, we have calculated the mean for the likers for protein and vitamin D. And we have also calculated x1 square, x2 square and x1 into x2. Here I have also calculated the grand mean, that is 4 and 9 we have taken together, and we have calculated grand mean average. And also by applying the formula of standard deviation, we have calculated standard deviation at 3.028, and we have mentioned that our grand mean for x1 bar, which is for protein, it is 6.5, and x2 it is 5.4. So we can see here we have applied the linear normal equation formula that to calculate the discriminant analysis, and the normal equations we have cited here also. See, we have what we have done here. Now x1, which stands for protein, and x2, which stands for vitamin D, the two groups are much more widely separated. If we were forced to choose just one of the variables, it would appear that x1 is better than x2. However, there is information provided by the group separation on x2. So we wonder if some linear composite of both x1 and x2 could be better than x1 alone. So accordingly, we have following linear function. As I said, we have the normal equations to solve on to find the value of x1 and x2. And the linear equation says z equal to k1 x1 plus k2 x2. So we know what is x1 and x2, but what is k1 and k2? Now these are the some specific weights we had given. We have sipped from the table, and we know that the discriminant function favors x1 by giving about 2.5 times weight to x1 that is given in x2. We can see here, see. So it was our likers and dislikers total. We found the total is 20, then 26.4, and this normal equation says the total of 16. Then after solving these normal equations, we found that k is equal to 0.368. What was k? It was k1. K1 means it is the weightage for the variable x1, and k2 is the weightage for the variable x2. Only one thing I want to say to interpret this result, that discriminant function z equal to 0.368 x1 minus 0.147 x2. It means what? Now if we see what is the value of a k1, now it was 0.368, which is a positive in nature, the number. It means what the weightage we had found from the equations, that supports X1, which is assigned for protein. But talking about the K2, it is very wonder to see that what is the value of K2? It is in negative 0.147. So, which is more required, or which one is more supported by the people? No, it is the protein, not the vitamin D. So that is why we can see, by seeing the equations, we can say that this is the positive one which is most supported by these two people, but this X2 which was assigned for vitamin D, it is not. Then, as we discussed, we are looking for two things: within the group variation and between the group variation. So here, with the help of these disliker and liker values, we have calculated for 5 persons. We have calculated the discriminant score and the persons assigned, or the number of persons for them, and we calculated the between group variability. Means if there is any variability between these two groups which we want to maximize, we calculated that is 5.96. Putting this value in the formula, we got this. And dislikers, if we calculate what is the differences of squares of dislikers, each is 0.772, and the same deviation from the group variability. Within the group variability, we calculated for likers, it is 0.772 divided by 1.544, and the discriminant criterion we have calculated, which is most important, is 3.86. Let us check it whether it is accepted or rejected as per our testing of hypothesis. We have explained here as since normal equations for solving K1 and K2, which we have already discussed, the mean protein is much important than the vitamin D. We have already found it. Let us see what is the next interpretation of these classifications. That the previous slides interpretations, that C factor is 3.86. I have assigned here. We can see the dislikers, the value was 0.824, and the likers, it was 2.368. Total of total mean of this likers and dislikers was 1.596. We can see here the assigned rule. What we found finally, that dislikers and likers, if we see the table assigned by rule as per the liker group table, we can see here disliker. It is okay, as because the same group, it is number of 5. But what about disliker and liker, as both are not overlapping with each other? They are mutually exclusive with each other. It says that is 0. Means they are purely, truly discriminant with each other in nature. Similarly, in liker and disliker, if we see, it is 0. It shows it was the appropriate assignment to apply the discriminant analysis. So all cases with discriminant scores that are on the left hand side of the midpoint, it was 1.596 to the disliker group. So there is a huge differences, or we can say variability in between the groups, which is actually required for the discriminant analysis, one of the objective. So it was the manual calculation we have done in the table, and few formula we have put it manually, but it is too difficult if we have n number of value and the data is too huge. In that case, it is not possible to calculate always by the help of manual calculation for discriminant analysis. That is why there is also options to calculate discriminant analysis by using the SPSS. So what we will do in SPSS, the problem formulation and identify the objectives. It is prior to using the SPSS. We have to identify What are the objective? As mentioned above, the objective of the study is to classify the consumer as loyal and disloyal, which I have cited in our previous slides. With us we have two groups. One, excuse me. We have two groups. One is loyal and the second one is disloyal. As we know, by listening these two names, we can say both are mutually exclusive with each other. Then, in order to classify the customers, the loyalty of the customers named purchase loyalty is considered the dependent variables, and the independent variables are the customer's purchase frequency in a year, and the average amount of spent on purchase in a year, and the number of years the consumer has been purchasing groceries from big basket. So the last three things are known as the independent variable, or we can say these are a set of independent variable, which is the most important objective of the discriminant analysis. Or we can say the multivariate analysis also. One independent variable, that is purchase loyalty, but it is actually impacted by these three or four independent variables. So what we will do here now, after choosing all the variables from SPSS, we will put purchase loyalty, which is a dependent variable. We will keep it in the grouping variable, and in independent variable, the terms I have said, that purchase frequencies, we can see here purchase frequency, then average amount spent on the purchase on a year, and number of year a customer has been purchasing groceries from big basket. So these are the independent variable, or you can say the set of independent variable we have selected for the independent variable box. Then we given in the dependent variable grouping variable, that is purchase loyalty. Then what is the next picture or the screen, the spaces? Let us see how it looks like. Now click defined range. Then the second one, this one will come, but before that we should discuss what are the steps to follow to get this screen in the SPSS. So what we have done, now as we know, there is whatever terms or whatever variables we have discussed, that is number of year, amounts, and minimum time of purchasing of the purchase frequency. Sorry, it is purchase frequency, average number, and the years. All are qualitative in nature. So what we have to do now, we have to assign some number or to code them. So here what I have written in click define range. In define range, what we will find here, no. In statistics, we will find defined range. We will enter as a minimum range and one as the maximum range. We can see here. In the defined range, we will select it. In minimum, we will give 1, and as maximum, we will give 2. After giving that, select statistics. If you select statistics, then select the mean. After selecting statistics, this screen will come, which is given in the left hand side of the slides. This screen will come, then we will select the mean. Then for univariate ANOVA, here as we are saying, in ANOVA is the only method or the statistical tool where we are calculating both within the group variability and between the group variability. Then box M in the descriptive statistics. See, this box will be ticked for descriptive statistics, and select unstandardized from function coefficients. See, in the function coefficients, instead of features, we will have to tick on standardized mark box. Then we will select within group correlation from matrix. So from matrices, we will have to select some within groups correlation. Then we will go for clicking continue. This is the process how we will operate in SPSS. So after that, classify option from the pop-up and select compute from group sizes for display, select summary table and leave it on the classification. What he says, from the pop-up select compute from group size. Prior probabilities, we have to go for compute for group size, not for all groups equal, as because we are interested in compute from group size in discriminant analysis. Then we will move to the covariances matrix. It's within the groups, as because we are talking about two things, within the group and between the groups. So that is why within the group. Then from display we have to select summary table for interpretation, which is the ultimate result of this analysis. Then leave one out of classification. Then we will go for the continue and OK. After completing all these steps or functions in SPSS for interpretation part, as we said, that after doing that a table will come with some result. So let us know how to interpret this result. So in strength of model, if we are talking about the strength of model from the result, we can see the classification result. We can observe that the discriminant function often can classify 76.7% of 30 consumers correctly. Of the 30 consumers, 7 consumers are misclassified. The most important part actually in the discriminant analysis, what he said, that 76.7% of original group cases correctly classified. But another 7 consumer customers are there, they are not, or we can say they are misclassified, means they may be overlapped. So this is about the strength of the model, and we can see it is the number of disloyal, loyal, and see here the total is 15 and here is 15. Percentage I have calculated, it is 100, not it is calculated by SPSS. Then coming to the statistical significance of the model, from the another table will definitely come from the outcomes, that Weeks lambda. Weeks lambda say is found that it is 0.560. Since the value of is almost closer to 0, this 0.560, it indicates better discriminating power of the for the model. What model or the strength we have defined for our model, it is actually very strengthful and good model, as because the 0.560 indicates that it is closer to 0. So it is a powerful model for calculating the discriminant analysis, and the significance is 0.002. It says confidence level of at least 99.8. As we have already discussed, the significant and confidence level. Now, as much as the significant value, it will be subtracted from 100. That is, will be known as our confidence level. Then the discriminant functions extracts account for the near 50% of the variance in the result of the eigenvalue table, confirming the hypothesis. We can see here, this is the significance value, and the null hypothesis of equal population covariances matrix is given, and the eigenvalue in the analysis box, we can say, see here, that the null hypothesis stating that there is no differences. As always we are doing that, null hypothesis always says the status quo situations. Here also it is true, as because the p value is 0.699, which is greater than 0.05. So in order to predict about this loyal 3 variables, that is better predictor of loyal and disloyal customers, we need to look at the standard coefficient, as we have already chosen. We can see here in a year to be best predictor variable with coefficient of 0.755 average amount. We had previously 3 independent variable: purchase frequency was, average amount, and years. It was 3.366. All are showing a very good analysis on standardized canonical discriminant function and the coefficients. And for classified, we can as because we have only 2 things, we can say disloyal is negative value, which is a negative impact, And for canonical discriminant function coefficient, we can see here the average purchase frequency is 0.028, average amount is 0.0006, and years is 0.354. So let us discuss why and what the presentation interpretation of these things is. See, in the D function, the function D says minus 4.023 plus 0.028 into purchase frequency, it is our independent variable. So as I discussed, one constant is there, it is calculated minus 0.4 minus 4.20023 at each in the equation, one coefficient then with the independent variable. So three independent variable we have placed with their coefficient, and we have calculated the D stands for the discriminant score for the customer whose purchase frequency and average amount spent in a year are known, along with the number of years for which the consumer has been purchasing groceries from Big Basket. So it is all about discriminant analysis, how it is helpful in our marketing research. Then we can go for the validation of the result, which is also significant, showing that cross validation is also carried out with a hit ratio of 73.3. See, for dislike, for likes, and for dislike it is 26.7, which is actually again a good symbol. So there are few applications also we have already discussed. In some independent or set of independent variable and only one dependent variable is there, then we must have to go for the discriminant analysis, and the core goal is to both predictor and or the dependent variable which group belongs to the same group, to both the predict which group and object and explain the reasons for that group membership using the independent variables. Basically, in marketing, we are using this discriminant analysis for predicting new product, whether it is success or failure, classifying male visitors, purchasers or non-purchasers, this categorizing sales executives as high and low performers. These are the basic examples where we should go for the discriminant analysis to get a ideal solution. Coming to the logistic regression analysis, it combines the independent variable to estimate the probability that a particular event will occur. And it is, as we know, regression is a predictor, or it is just predicting another variables when one variable has value is given. But here in the logistic regression, we are using some probability value to ascertain the situation very more accurately. So in logistic regression analysis, dependent variables do not need not to the interval normally distributed, linearly related or equal variances within each group, which is partially occurred in the discriminant analysis or multivariate analysis. As we can see here, the equation for the logistic regression, y is equal to e to the power b0 b1 x1 plus up to bn xn divided by 1 plus e to the power same b0 plus b1 x1 plus up to bn xn. So what are these small x1 x2 up to xn? Now these are the input values. The number of value I have for the input that will be placed in the power of the epsilon or E, I can say. Y, the small y is the predicted outcome or output, we can say. As in the regression equation, beta 0 is the intercept term, and the beta 1 up to beta 2, beta 3, these are known as the coefficient for output. And the logistic probability function must always be positive. As we know, probability will never be negative. Negative is the law of the probability and will never exceed 1. So these are the key properties of the linear logistic regression analysis. Logistic regressions depend Dependent variable obeys Bornell distribution, which are talking about discrete probability distribution, Bornell distributions, and estimations or prediction is based on maximum likelihood that will be discussed in the chapter. Then logistic regression does not evaluate the coefficient of determinations, as because it is not just like linear regression analysis. We discussed about binary or Bernoulli distribution, as we are saying that Bernoulli in probability distribution, Bernoulli distribution says there are two things, either success or failure, pass or fail, head and tail. When there are only two possibility, then we will go for the Bernoulli distribution, and the number of experiment is very finite in nature, which is countable in nature, we can say. So this predicts the probability that the observations falls into one of the two categories, or we can say dichotomous in nature. Similarly, in the second type of logistic regression is multinomial logistic regression, it is known as, and it is sometimes considered an extension of binomial logistic regression having the dependent variable with more than two categories. It also uses maximum likelihood estimation to evaluate the probability of occurrence of the independent variable. And the third type of regression, logistic regression, is ordinal logistic regression. Here, the dependent variables in ordinal logistic regression is not only used categorical, but they also follow some order. For example, the performance of sales manager in whether it is poor, fair, good, excellent, or a customer is highly dissatisfied, satisfied, or highly satisfied. All these categories are included in ordinary logistic regression. So if we see the use of SPSS in logistic regression the same way as mentioned, then to find the objective of the logistic regression as mentioned above. Objective of the study is to classify the customer based on their preferences for two brands of coffees, namely Brew and Nescafe, if it is. By using logistic regression with SPSS, we will see how it is. After finalizing the objective, then we will go to the step 2, that is research design for logistic regression. In this steps, what we are involving now, we are selecting the dependent and independent variables under study. In order to classify the customers based on their coffee and brand preferences, like choice of brand is considered as the dependent variable, but the independent variables are age, as because when our increases, the taste may change. So what happens here? Now the age is a factor which is changing the choice of brand. Similarly, income, the high earned income group will choose the costly coffee brand. So these are the independent variable, but the dependent variable is the coffee brand. So what we have done, we have selected the variables. Brew is 0 and Nescafe is 1, we have coded. Then we came to analyze. After that, we select regression. From regression, we have chosen the logistic regression. Two-stage logistic regression. After that, this screen will come, logistic regression. What we have to do now, what we have defined, the age, income, whatever the factors which are actually the independent variable that we have to select to the right hand side of the box here. After doing that, we move to this logistic regression options. The screen will be look like that. It contains some statistics and plots. Under that, we have classification plots, Homser, Lemshow, goodness of fit, then case-wise listing, residuals. All these things are given, but as per the requirement of the researcher, we need to check what to be calculated and that to be ticked mark. So the steps I have mentioned here, click on options, then we will go for the logistic regressions. Then From that, we move to statistics and plots, which is given in the right hand side. Then we click classification plots, as it is required for my research or for the marketing research what is undergone. Then we have also select the second option, that Thomson and Lemso goodness of fit. Then we have also clicked case-wise listing of residuals. As outlier outside, I have only two that is mentioned here, and CI. Then we have clicked for sorry, it is CL for experiment of B. I have ticked also that because it is 95%. Then we clicked OK. Then, after choosing that or clicking on OK, I got the strength of the model table, that is classification table, and another model summary. So here you can see the brew, the persons those are preferring brew, and the choice of people of Nescafe, that is mentioned here, 26 and 5, 4 and 25 over here. The percentage actually correctly calculated, it is 83.9 for brew and 86.2 for Nescafe. The overall percentage is 85 percentage. And we can see here the cutoff value is zero point 0.5. Let us see how it is helping us in interpreting the values. And another table we have found, that is variance explained actually in that model. But the table will be shown by the SPSS, it is known as model summary. In model summary, what is shown? Log likelihood, Cox and Snell R squares and Naxter R square value has given. It is 39.7375A. What is it? A. Now it is estimation terminated at iteration number 6 because the parameter estimates changes by less than 0.1. That is why this value has come like this. And how it is significant, let us see. In the variable equation we have found by SPSS, what is given, see. The independent variable was age, gender, income and other constant, that is ultimately with the equation of the multiple regression analysis, logistic regression analysis. The constant is here, having the value is minus 5.895. So you can see here, age, standard error is 0.42 and the same for gender, it is 1.261, and the other values are there and the degrees of freedom here. But just check the significance level. For age it is 1.184 and for gender it is 0.003 and same for income, and it is very less for constant. Then, since the probability is greater than 5, the customer is classified as preferring the second brand, that is Nescafe. And if the probability was less than 0.05, then the customer is classified as preferring the first brand, that is brew coffee. And this is the most important part we should have to discuss. What he said, now since the probability is greater than 5, 0.5, what is my p value? The p value says it is higher than the 0.5. What is 0.5 again? That is the level of significance value, and my probability value is greater than that. It says that the preference of brand of coffee, that is Nescafe, is the consumer is classified as preferring the second brand, which is actually Nescafe. But if the value or the result if it is vice versa, means the less than 0.5, what will be the interpretation? Instead of 0.5, if it is less than 0.5, then ultimately Nescafe will be rejected, but brew will be accepted. You can see here the cutoff value was 0.5, with whom I was explaining or I was validating the result. External validity supported with the Hit ratio of the selected holdout sample, also referred as to the validation of sample, which is separate from the analysis sample, and it is estimated that 85% overall percentage. The result. The same way, application of logistic regression in data-driven decision supports, we should use logistic regression analysis, and ideal for non-normal social science data. Basically, we require the logistic regression analysis, and in predictive binary groups where two things are there, likelihood estimation or probability concept is to use. In that case, we should go for the logistic regression. Then wide range of marketing application like common uses include credit risk assessment and predicting purchase behavior, or any other marketing activities. We should go for the logistic regression analysis for identifying success factor in the research. If we differentiate with these two, we can say both techniques requires categorical variables, and logistic regression is preferred when the dependent variable is dichotomous, means yes or no, choose or not to choose, use or not choose. But while in discriminant analysis is preferred when the dependent variable is nominal in nature. Logistic regression is often used by researchers when they are interested in finding the most important predictor, or in the findings the role different variables play in the prediction. So while logistic regression emphasizes on the predictors, discriminant analysis emphasizes on the group prediction itself. So it was all about the differences and uses of discriminant analysis and logistic regression analysis. In summary, we can say that both discriminant analysis and logistic regression are multivariate techniques used to predict the probability and the observation belonging to the specific category of dependent variables. And the core assumption differences we have discussed, that the fundamental distinction lies in their assumption about the predictor variables distribution, and the discriminant analysis requires the predictors to be normally distributed within all group of the dependent variables, while logistic regression makes no such distributional assumption about the predictors. Population distribution, if we see, discriminant analysis is theoretically appropriate when population distribution is multivariate, normal for the predictors within the group, and logistic regression is distribution free. It may be normal, it may not be normal, or you can say skewed, but no, logistic regression can be applied. Assumptions also discussed that the unit of explicitly covered the specific assumption underlying the application of the each methods, highlighting their importance of the valid results and the calculation procedure and the interpretations. And also we have seen how this multivariate, this discriminant analysis and logistic regression we have calculated by using the SPSS statistical software package. Both we have discussed, and we have also discussed what is the differentiation between these two, what are the different situations where we should go for discriminant analysis, but where the logistic regression analysis is not to go, and where the logistic regression is most appropriate but discriminant analysis is not to use. In the learning context, we can say the concepts and software's applications were explained and reinforced through the use of hypothetical cases and examples. So we can say here, no doubt it is the extension, or the it is derived from the correlation and regression chapters. But when it is extend, or some specific situation come to us in a real world, we will think about this discriminant analysis and logistic regression analysis. Depending on the situations, depending on the distribution and the probability assertment of the value or the result or the set of independent variables, what are the actually included in these two, we have to take the decision which one is applicable or which will be the best tools or techniques to conclude our research or to interpret our result to reach at our goal. So it was all about the discriminant analysis and logistic regression analysis we talked about, and how we will use in the research of marketing research, that also has been discussed, and the predictive probability, categorical independent and dependent things I have discussed in this chapter. In the next chapter we will look forward some other aspect of the research or the statistical tools and techniques how we will use in our research, that we will discuss.